back to solving trig equations. You have 2 in front of you, and before I do anything else, of course, you must write these down. And then, honestly, you can solve these. There's a big keyword I'll give you in just a moment. So go get to it. You're only still listening at this point if you've already written them down and attempted to solve these trig equations. I know they look cumbersome, but they're not unsolvable, Avi. Big key then is factoring. On this second problem, you probably haven't looked at it yet, so you should. Okay, now that you've looked at both of them, both of these are solved by factoring. The second one, that thing that we call the greatest common factor, and the top one, FOIL, or the method you guys commonly use, Xbox. Yeah, that's right. So look, in the top one, I've got to find the factor groups. I do my this, and my this, and my this, and my this. And if it's too weird for you to do Xbox with cosines, we can say that A is equal to cosine. That doesn't mean anything, right? I'm just going to rewrite it, all right? So look, so that means I can rewrite this equation as 4a squared minus 2a minus 2, all right? That one you can definitely factor, so do that. Do both of these now. So going quickly through it, right, I multiply these two together, and I get a negative 8a squared, negative 2a on the bottom. I've got to have something that multiplies to be the top and that adds to be the bottom. The only thing I can think of would be a negative 4a and a positive 2a. That adds to be a negative 2a and it multiplies to be a negative 8a squared. And we fill out our box by throwing all this stuff in it. So I have 4a squared, negative 2, negative 4a, and 2a, right? Those go in there too. So what do these guys have in common? Well, it looks like that has a 4a in common. These have an a in common. These have a 2 in common, and a negative 1. That means I can now rewrite my expression, right, as 4a plus 2 times a minus 1. But we just did all this stuff to make it more aesthetic, in other words, to make it look nicer, right, because we know a is cosine, so we just rewrite that now. So it's 4 cosine plus 2 cosine minus 1. All right, now we have factor groups, which means now we can do something, right? We can set each of these equal to 0 and solve for cosine. And the same thing will apply to here. Let me quickly show you what happens here. What do these both have in common? Well, they both have in common a cosine. I pull out the cosine. What's left here? Yeah, 2 cosine. What's left here? No, not 0. 1 is left there. So now I have 2 factor groups here. Set both of those equal to 0 and solve. If you're still, if you're listening, that you've solved both of the factor groups for problem 1 and for problem 2. Okay, so if you haven't, just stop. Just stop. Okay, so now that you have, look, I found that over here, right, that's the same, this thing is the same as cosine x is a negative 1/2, right? I solved for cosine, I got that. This is the same thing as cosine x equal to 1. So I got x is 0 and 2 pi here, x is 2 pi over 3 and 4 pi over 3 here. I'm not done. How often do these values repeat? Yeah, they repeat on the period. So if I'm going to do this properly, I've got to say that x is equal to all of these, right? 2 pi over 3 plus 2 pi k, 4 pi over 3 plus 2 pi k. And I can pick either of these, right? There's 2 pi apart, so I'll just pick 0 and write 2 pi k, any integer. Done with that problem. Let's move up. Look, here are my solutions for those, so it's the same issue. I just write x is pi over 2 plus 2 pi k. 3 pi over 2 plus 2 pi k. Pi over 3 plus 2 pi k. 5 pi over 3 plus 2 pi k, where k is any integer. Now look, here's your question, alright? I'll see if I can get it right. Here's your question. Why do we put the k? Like, do we always put the k? And the answer is no, we don't always put the k. What's really happening here, what I haven't written, is it'll say this thing across, right, the interval here to here. And when you see that, right, which can also be written like this, all real numbers, that means that I have to account for every single solution that happens, right? And these sinusoidal functions are periodic, which means they repeat over and over and over again. So I've got to talk about every one of these solutions. The only way to do that is to add this 2 pi k. That's the only way to talk about and do it properly. Now there are other times, which we'll get into very soon, where it'll say across this interval, a specific interval, in which case you'll only list specific answers. But we'll get to that next time.